fourth example in this miscellaneous type, with a focus on the number of terms. We can see with this one here, this one's a little bit different in that it's got, they're summing to 3n terms. And whenever you see something like that, to 3n terms, you can be pretty sure that it's going to have 3 separate series within the series that's given. And let's have a look at that, and we'll be able to see how that is here. So if we have a look, we've got our first term here is just 2, and if you look at there, the fourth term is also a 2, and the fifth, sixth, seventh term is also a 2. Okay, so we've, first of all, we've got a series there. Let's have a look. Let's let Sn represent the series, and so we've got 2 plus 2 plus 2 and so on. Okay, that's one series. The next one we've got here is 3. Skip past the next 2 and it's a 5. Skip past the next 2 and it's a 7. So we can see there 3, 5, 7. We've got a distinct pattern there. Okay, 3 plus 5 plus 7. Again, looks like we've got an arithmetic series there. And plus our third one. Okay, 2 squared, 2 cubed, 2 to the power of 4. Okay, so it is, so we can write that down there. 2 squared plus 2 to the power of 3 plus 2 to the power of 4. Okay, now we remember with the previous ones we had to make sure that each of these separate series, the number of terms there had to add to what was given in the question. And so we can do that here. You can see that first one to n terms, second one to n terms, and the third one also to n terms. So the number of terms in each of those separate sequences has to add to 3n, and it does. Okay, now where to now? Well, we need to remember, write it in such a way that we can express it in terms of the rth term. Well, if we have a look, our first one here is fairly straightforward. That's just going to be the sum from r equals 1 to n of the number 2. The second, okay, is from, again, from r equals 1 to n terms of 2r plus 1. So we've got that there. How do we work out that? Again, it's increasing by 2 each time, so it's 2 times r. 2 1s are 2 plus 1 is 3, so we know it's plus 1. Another way to think of it is we can recognise there that it's an arithmetic progression with a equaling 3 and our common difference equaling 2. So we wouldn't have to necessarily use the result. We could use the result from the formula sheet, or we could use the fact that it's an arithmetic progression and use our formula from that. Okay. The third one here, we can see that this is a geometric progression to n terms. Okay, a, where a is 4 or 2 squared, and r equals 2. Okay, so let's go from there. Now that this one here, it simplifies when we get rid of the sigma, that is 2n. Okay, so we're going to then add, remember, sum to n terms of an arithmetic progression or an arithmetic series is n over 2 outside of 2a plus n minus 1d. And the sum to n terms of a geometric progression is a outside of 1 minus r to the n over 1 minus r. So we can just use that, excuse me. So we've got 2n plus n over 2 outside of 2 times our value for a is 3 plus n minus 1 times the value for d, which is 2. That's for our arithmetic series, and for our geometric series, a is 4, 1 minus our r value is 2, so it's 2 to the power of n over 1 minus 2. And going on further, 2n plus n over 2 times 2 3s are 6 plus 2n minus 2 minus 4 outside of 1 minus 2 to the n, and 2n plus n over 2 outside of 6 minus 2 is 4, 4 plus 2n minus 4 plus 4 times 2 to the n. Okay, it's just a matter of simplifying here where we can, as much as we can. So we can take out a common factor there. That's 2n 2 plus n over 2 minus 4 plus, now 4 can be written as 2 squared, so 2 squared times 2 to the n will be 2 to the n plus 2. So let's get our last line here. The 2's will cancel, and we'll actually have one more after this. The 2's are going to cancel there, and then 2 times n is 2n plus n squared minus 4 plus 2 to the n plus 2. And scrolling down a bit more. Okay. N squared plus 4n minus 4 plus 2 to the n plus 2, and that is our answer. That's our sum to 3n terms, and I think I need to go up because I've written over here as Sn, but it should be S3n, sum to 3n terms. Okay, which is important because the next step of our excuse me, the next part of our question asks us to find the sum of the series to 33 terms. So that means we need to let 3n equal 33. Okay, because we want to substitute for n. That means n equals 11. Okay, so then it's just a case of the sum to 33 terms equals 11 squared plus 4 times 11 minus 4 plus 2 to the power of 11 plus 2, and we can put that all in our calculator, and our answer is 8,353.